Scheduling system for integrated automated container terminal. We were working at a company on the East Coast. We were working at terminals in Halifax, Nova Scotia, Charleston, and South Carolina. Our objective was to build a yard plan and scheduling algorithms for these automated container terminals. When the ship comes into berth at the terminal, the containers are scheduled to come off the ship, are taken off, and the containers that are going to go on. These ships typically go around the world. For example, they start in Rotterdam, then go to Halifax, Charleston, Miami, through the Panama Canal, up the West Coast, across the Pacific, and so on. The container ships typically have 5,000 to 6,000 containers on them, and at any given port will typically pull off and put on 500 containers. Our benchmark problem was to take 500 containers and plan how to handle them in the container yard so that they could be put onto the ship most efficiently. What do I mean by most efficiently? Well, we had two goals here. One is to get the computation time down. It was taking them 35 hours to do a yard plan. They were literally doing it with pencil and paper. They contracted with a company to develop an intelligent agent system that would generate the plan for them, and they were successful in doing that, but it still took 35 minutes to plan a yard plan. Although this is a huge improvement on the previous system, but what happens when a crane breaks down? What happens when a holster truck breaks down? What happens when a hot box arrives at the front gate and has to go on the ship immediately? Things like that they were not able to handle because it took them 35 minutes to generate a yard plan. The other thing they were looking at is how many times the containers were touched. The system developed by hand averaged about 3 touches a container, averaging 1,800 touches for the whole lot. The intelligent agent system improved that quite a bit and got it down to a total of 1,200 touches. So we were trying to get something that would work fast and keep the average number of touches low. Our planning software using Swarm reduced the time from 35 minutes to 1.4 seconds, and we reduced the number of touches typically fewer than 600. So we were able to plan blindingly faster than they were and get the number of touches down.